Okay, yesterday we started what are called string functions in C#, and I gave you some problems to try. So what I want to do to start off today's lesson is take those questions up first, and then we'll take a look at a new topic called string accumulators, a little bit more advanced idea. So here are the three questions I gave you for homework. And let's take a look at the first one. The first one says, write a program which will accept a sentence as data and determine the number of vowels. So remember, whenever you start off a topic, if you're not sure of yourself, just use the programs that we did in class and maybe just copy and paste them and change them. So this program you're looking at right now is called letter count. And what I did is I basically copy and pasted this example right here, and I dropped it into each one of these questions, and I used that as my starting point. Now this first problem just basically is almost exactly like this one. This one was just looking for the number of letter A's there were in a sentence, right? So I had an if statement with just, if you found an A, count it. Well, vowels, A, E, I, O, U, and I guess sometimes it's a Y also, but I'm just going to stick with A, E, I, O, U. So all I did for the first answer is I wrote down exactly word for word all of them. I changed this counter to counter V for vowels, and this is the most important line that I changed. That's how you say, is it an A, or an I, or an E, or an O, or a U. Okay, and that's the symbol for or. Another common mistake you might make is you always have to use two equal signs when you have to use, like, is this equal to that? All right, and that's the answer to the first one. It's just one big long if statement. Second question. Second question is challenging for a number of reasons. And actually, even my solution isn't totally right. And you could really make this a really challenging question. But let's just try to do a simplistic answer just to prove that we understand some of the ideas. The most important idea is I'm looking for the word the this time. The is not a one-letter word. If you're not sure what I mean, you know the one I just did? And we were telling the computer, grab I, comma 1. What that would basically mean is go to one letter and grab it. Go to the next letter and grab it, and always just grab one. Well, if you're looking for the word the, that's a three-letter word, right? So this is the first simplistic answer, but it's not totally right, but for our purposes right now it's good enough. So obviously you ask the person for a sentence. Here's my counter this time, count the. And here's a couple of major changes. First one, which I hope you got, was this. You're going to be grabbing three letters at a time. Not one, because the is a three-letter word. And then obviously you change your if statement to the. Here's the other tricky part. Do you really need to go to the last thing? Like usually we've got it written like this, right? Matter of fact, you'll get an error actually if you go to the last thing. I'm going to run it right now like this just to show you, because I'm grabbing three letters at a time. So when I get near the end, let's say I was on the very last letter. If I try to grab three letters from the last letter, where am I going? There's nothing there. Let's see the computer actually yells at me because of that. So this is problem number 2, and I'm going to just type in the, and I'm going to press OK. Well, it did give me an error. Okay, index and length must refer to a location within the string. So obviously I'm on number 5 right now, and I'm going to grab 5, 6, and 7. Well, I don't think there is 7. Okay, remember 7 is actually the length, but it's 6. So I actually would have gone one over than where I'm supposed to be. So you've got to sort of backtrack a couple. So you want to go one over, and then you got to go one back. So actually, you might do a little bit of trial and error, but I think I'm going to have to go back 2 from where I am, because it's 3 altogether. So I'm going to count that one. So let's just actually see for a second if that works out. So the total number is 2. Okay, so that's reasonable. It seems to be working. So this is where you get into that mindset. Oh, so this is going to get tricky, and you're right. And this could lead to a really, really complicated question, but I'm trying to make it as simplistic as possible. But look at this. What about this combination? These are, there are, like, see, there's does in these, right? But I wonder if the computer is going to come back and say, there's 2 of them, because really there isn't 2 thes. They're inside of these words, but they're not really the actual word the. Let's see what it says. Yeah, it said 2, so that's a mistake. So how would you handle that? Well, then you start getting crazy, because then you're really just looking for the with nothing in between. Okay, but now what you've done is you've made it a 5-letter word, so you got to change that to 5. Make it a 5-letter word, you got to take that off. So it starts getting crazy. Okay, so for our purposes, all I wanted you to realize in this question was that this has to be changed because it's 3-letter words, and you go to the very end there. Okay, last question is the trickiest. You're supposed to be given any length word, and I want you to pull out the middle character. Now, this is almost like this concept in math called median, where you figure out the middle of a bunch of numbers. So actually, the first thing you have to realize is if it's a 5-letter word, yeah, there's a middle. It's the third one. But if it's 6 letters, there is no real middle. So you have to only accept odd characters, odd number of characters. So how do you tell that to the computer? Well, this is what I'm going to show you. We're first of all going to have a loop that goes like this. And here is how you tell the computer it's an odd number. What you do is you figure out the length of the word and you divide it by 2. So when you get 5 divided by 2, there's 1 left over. Okay, so do this while you don't have a leftover, which means it's an even number, because you're going to keep asking the person, listen, it's not an even, it's not an odd number, it's not an odd number. Watch what I'm going to do. I'm going to type in, oops, the wrong one. So let me just try this for a second. Okay, so let's go to this question right here. So let's type in this. That's 4 letters. No good. It's going to ask me again. Let's type in the. It's H. There's a middle. Okay? So let's take a look at the last part of what I have to do. So once I realize that I do have an odd length word, now I got to figure out the middle. To figure out the middle, now think about this. If it was a 3-letter word, the middle is 2. So what you do is you take the length and you add 1 more and you divide it by 2. Oh, but then, sir, what are you taking away 1 for? Because remember, we don't start at 1 when we do strings. We start at 0. So really, the beginning has to be 0, so you take 1 away. Okay, today's topic is string accumulators, and the program that I'm going to use to introduce this idea is, surprise, surprise, called String Accumulators, and we'll load it up. All right, String Accumulators, kind of a weird name, eh? Well, when you add 1 plus 1, you get 2, right? But if you actually put quotes around 1 plus 1, you'd get 11, all right? And that's the idea I want to introduce today, that there's a way to attach things that have quotes on it. So why would you ever want to do that? Well, as we get more sophisticated, I'm going to show you a couple of examples tomorrow, and you do these things called code validations, encoding and decoding. What happens is you take numbers and you rearrange them and join them up in different ways. And we're not adding them, we're pulling them apart and we're rearranging them, and that's what happens when you code things, right? So you have to learn the skill of how do you take stuff, take it apart, maybe put it in backwards, rearrange the letters in a different way, or rearrange the numbers so they're encoded, and it all is based on this thing called string accumulators. I'll quickly show you the first example and then we'll talk about how it was done. So I'll type in a word, okay, Hamilton, and when I press OK, I've reversed Hamilton, okay, backwards. So what I've done is I've reattached Hamilton in reverse. To reattach stuff, we're going to do this thing called a string accumulator. So it looks like that one question you guys did when you had to work out averages. You're going to be totaling things up, but it's going to be words, but not numbers. So remember when we total stuff up, you always start your totals at 0, right? Well, in computer, when you say 0 for words, it's 2 quotes stuck right together. Not a space. No space. Stuck right together. That's called a null string. Then you ask the person for a word, and remember, I wanted to reattach these words backwards. So I start at the back of the word, okay? And you notice I don't go to word length, because if it's like a 10-letter word, the 10th letter is actually 9, because it starts at 0. So that's why it's word minus 1. Now we do go to 0 because there is a 0, and we're going backwards, so it's minus minus. And this line right here, what it does, it looks like that thing where you go counter equals counter plus something, but it's for words because reverse is a string. So this reattaches everything backwards. And I'll use my F11 technique to step through it just to show you what's going on in slow motion behind your back. Okay, so like I said, you are going to start, it's going to ask you for a word, and I'll just type in ham this time, not the whole thing. Okay, so we start from the back, All right, and we're going to work our way up. Now, the back in ham is 2. Remember, it's a 3-letter word, but it's 2. So what I'm doing right now is I'm attaching the last letter in ham, which is the M. So watch what happens after it's done. I've got an M. Let's go back up. Okay, now we're on, so I was on 2, I'm on 1, which is the second letter in ham, which is the A, right? So I'm going to pull that out and watch what happens. M-A. It's always attached to the behind, right? And one more time. All right, so this is going to be 0 this time. All right, and 0 is the H, and when I pull it out, you get that. Okay, and then obviously it prints out the answer. All right, so that's the theory of this thing called string accumulators. And based on this idea, you can do all kinds of neat stuff. What we're going to do in this class is take a look at a couple of problems that involve numbers, because eventually tomorrow I want to show you how to do code validation. So here's kind of a neat example. Okay, so I'm going to enter a number 1, 2, 3, 4, 5, 6. Okay, and what this program did is it took the number and then reversed it and then added them together. All right, and now we're starting to see some of the crazy stuff that you're going to see tomorrow, because when people invent like these special codes, they do all kinds of weird things to them. They'll take every other number and reattach it, and then double that number, and then flip it around, and then they'll come up with some answer, and if it's divisible by 10, it's a valid code, or something like that. Okay, so they do all kinds of neat things that involve this manipulation. Let's take a look at how I did this question. Okay, so just like before, I'm going to ask the person for a number, and looks like I'm going to reverse it again. You don't always reverse it, by the way. It just happens for this question that you do it. Sometimes you do some other stuff to it. So this could be any variable. So like I said, in this one, you do reverse it. So you're given a number, make up any number you want. And what this computer program does is it goes from the end to the beginning and reverses it. So now you've got the original number the person gave you. Okay, and notice, sir, you're doing numbers. How come they're all strings? Because that's the way it goes. When you do even number questions that are codes, you make them always strings. At the very end, you may do some math on them, but you're always manipulating them this way. So in this particular example, I have the original number, which is a string. I have this new one, which is, in quotes, another string. And now I want to add them together like for real, mathematically, not string-wise. So I did my string stuff up here. So notice now, I take the original number and take the quotes off of it. The original number reversed, take the quotes off of it, and now I get an actual answer. But you see yourself going back and forth, and this prints out the final answer. And again, look at, after you get the answer, you put it back to a string when you want to display it in a text box. Okay, so one more time. And this works for any size number, but I'll do it fairly small this time. 4, 5, 6. Okay, oops, this number here, 4, 5, 6. All right, so there's 4, 5, 6, there's 5, 6, 4, and when you add them together, you get 1,110. Okay, and that's the basic idea, and you're going to use this as the basis of some problems you're going to try on the problem sheet. Questions that you're going to be given are questions 2 and 3 on the problem sheet.